Ah, oh my gosh. Delete that off. Oops. You silly thing. This thing's driving me nuts. All right. This is why it's so much easier just in person, in class, right, with just a whiteboard. I don't make all those little mistakes. And so here we're going to do plus or minus, oops, plus or minus 2.571 is our critical value, okay? And just in case, if we're wondering what that means or what we're talking about here, right? When we have to make a decision at the end, we're going to use those critical values of negative 2.571 right here and 2.571 on the positive end to see where our t-value hits, right? Is it going to find its way into the rejection region or is it not? Okay, so I just typed it here like this, and you can just write it like that too, okay? You do not have to draw this. I'm just drawing it for you so you have a visual idea of what these numbers are for us, okay, what they're gonna do for us. Okay, I'm gonna erase it real quick just because I think it's gonna probably, or okay, or not, it's not letting me erase it. Oh, there we go. Okay, of course, with the, let me just do this real quick. Okay. All right, so now step 3, right? Step 3 is the big one. It's all these calculations. It's everything we have been working up for at this point, okay? Everything we've been doing. You're like, well, thank God. I'm glad we're finally getting to do something that we're supposed to. All right, calculations. Oops. If I could spell, it always makes this stuff so much easier, okay? Calculations. Now this part, I can't type, right? I can't type this part. So I'm gonna say, or just, we're gonna do this on the next slide, okay? Okay.
So you're always looking at the two-tailed test with 0.05?
Yeah, Natalia, yes. In this class, really in kind of beginning statistics, especially in social sciences, we do a two-tailed 0.05. And the reason for that is the two-tailed is more conservative. Okay, it's a more conservative value. And 0.05 is just that's just what we do. Okay, now if you went on in statistics, they might change their requirement of what you want to do, okay, or what they want you to do. And they might say, test this at a one-tailed 0.01, okay? Or they might say, test this at a two-tailed 0.01. So they might differentiate what they want you to look at, and that's okay, right? We know how to use this table, so you could do that if they want you to. So here's one tail, right? And every statistics book has these, and they're all kind of formatted the same way, okay? So here's, if they said, do test a one tail 0.05, okay, we have a degrees of freedom of 5. Our critical value would be this now. If they wanted you to do a two-tailed 0.01, our critical value would be here.
Okay.
Okay. It just depends. And that's only if they tell you what they want you to test. If it's never said, if it's never stated, just your automatic thing would be a two-tailed 0.05.
Okay.
Okay, that's like the default,
Oh,
unless it's specified. Okay, and that's we can find those, right? So if I said do a two-tailed 0.01, then in step 2, our critical value would be 4.032.
okay.
Okay, but in here, I just go with this because this is what is mostly used. Okay, this is what's mostly used, a two-tailed 0.05. Okay, is that okay?
No, it is.
Okay.
Thank you.
Good question. Thanks for asking that. Okay, guys, now we get to do the number crunching. Okay, so I'm gonna put this stuff over here because we're just gonna need that. We don't really need degrees of freedom anymore. The only time we need degrees of freedom is when we find our critical values. And so we already did step 2, we already found our critical values, so you don't really need degrees of freedom anymore, but I'm gonna keep it here just in case if we're wondering what, you know, what we're doing, right? I'm going to switch and just use black here real quick. So I like to do this. I like to draw a line here, okay? Because we're going to need a few values. If we look back at all of our my scribble scrabble here. If we look back at this and we see that what values or what numbers we need. We need n, and we have it. We need our sum of our x's squared, and we need our sum of x. Okay, so those are two values that we need in order to complete this formula. Okay, so let's go back to this slide. We need our sum of x, and we're going to need our sum of our x's squared. Okay. So our sum of x is just found by, hey, oh, it might be being blocked by antivirus software. Okay, sorry guys, I just saw that and I was like, hey, there's something on here about my camera. Okay, I'll look at that later. All right, here's my calculator. Okay, so we need to add up all of these x's to get our sum of x. Okay, so we need to do 59.1 plus 60 plus 58.6 plus 60.2 plus 60.8 plus 62.1. And I get 360.8. Yeah, did someone else do that too? Oh yeah, awesome. Thank you, Christy. I always like someone to check me because, oh, you never know. I could certainly push something wrong. So 360.8, is that what we said? It's kind of annoying. As soon as I, as soon as I start writing, it makes my calculator disappear. Okay. Yay, look at that. We've now have two numbers that we need for that formula. Okay. Now we need our x's squared. Okay, our x's squared. So we have to take 59.1 and square it. 60 and square it. 58.6 and square it. Okay, so 50, oops, hold on, let me use my keyboard because that doesn't work very well. So 59.1 squared, look, we could just push this little button right here. Oh my gosh, does that make sense? I don't trust it. Is that what did anybody else get that? Christy, did you get that?
Yeah, that's what I got.
Oh, wow. Okay. So that's we got some big numbers here, right? So 59.1 squared, yes, is 3,000. I'm going to type it instead of trying to write it because I don't really trust my typing here. So we got 3,492.81. Anybody scared of big numbers? That's a common thing that we have. But you know what people never say? They never say they're scared of really small numbers, even though they could have the same number of digits, right? Okay, 6t squared, I can just tell you it's going to be 3,600. 58.6 squared is 3,433.96. 60.2 squared is 3,624.04. Oops, I didn't mean to do that. And oops, and 60.8 is going to be bigger than that last one, and it'll be 3,696.64. And then this is going to be our biggest one of all, 62.1 squared is 3,856.41. Oh my goodness. Lots of big numbers here, right? Okay, so now to get our sum of our x's squared, we just add up this column. Okay, we just add up all these big numbers here, all right? And that's okay, we can do it, okay? So 3492.81 plus 3,600 plus 3433.93 plus 3624.04, 3696.64, and 3856.41, and I get a grand total of 21,703.83. Christy, if you're doing that one, you let me know if that's right, if you got the same value.
Yes, that's the same value.
Same one. All right, good. Okay. So let's see. As soon as I try and do this, it's going to 21,703. 0.83. Oh, that didn't work. 0.83. Is that right? Did I? Okay.
Wasn't it 86? Or it doesn't matter?
Well, I had 83. I had 83.
Oh, okay. I see my problem now.
You got it?
Yes.
Okay. 13. Yeah, should end in a 3. But I don't know. Sometimes we punch numbers wrong. Like you said, Christy, in the grand scheme of things, that probably wouldn't make much of a difference. Okay. But it's always good to clarify, right? Okay, so now going back to this, looking at this formula, we have all the pieces that we need to start this whole process. I'm so excited, right? Are you guys excited? Sorry, guys. Guys, go get him out, Matthew. Okay,
Do we always do that kind of step for the other like problems, or is it's
Yeah.
just on the problem?
Yeah, we're pretty much going to always have to do that.
Okay.
And if you remember all the way back in chapter 4, when I said you guys are going to be so sick of calculating standard deviation and you're going to be able to do it in your sleep, this is what I meant. Because every single time we have to do this. Okay, we're just going to have to start this off.
No, it's fine.
Okay, I'm going to, just to save space, I'm not going to retype the actual formula right here. Okay, because it's right here. You guys can look back, or you probably have it very easily on your notes, maybe right there in front of you. I'm just going to fill them in right here. Okay, I'm going to go ahead and fill it in. So the first number is always your bigger number. It's the sum of the x's squared goes first. Okay, so our big number is going to go first, and that's going to be that 21,000. Oh my gosh, 703.83. That looks really bad, and I don't know how to type or write it any better. 21, oops, 703. This is a little bit better, huh? 83 minus
It's 0.83.
0.83. Yeah. Do you see that right there? I don't know if I did it very well. When you added up all of these, came to point.
The point. Oh, okay, never mind.
I know you can't see it very well, huh? 0.83. That didn't get any better. Minus, here is where we put our sum of x, and that was the 360.8. We are going to square that eventually. We're going to divide this by our n, and then the whole thing is going to be over n minus 1. Oh my gosh. I'm going to have
Isn't our N 5 or no?
No, n is 6. N is 6. Remember, degrees of freedom is 5. Our degrees of freedom is equal to n minus 1. Okay, yeah, that's so good. I'm so glad you guys are asking questions and clarifying, okay? Please keep doing that, because I promise you it helps everyone. Trying to make my house big enough to fit everything in there, all right? Okay, with standard deviation, remember, it's always easiest to kind of do this stuff first over here. Okay, let's do all of this over here first. So that means I have to write this annoying number again. Minus. Now, let's see this. This 360.8 squared is going to be a ginormous number. Look, let's see, let's do it right here. Where'd my calculator go? Did I close it? Okay. So 360.8 squared is this huge number. Okay. Technically, it would go right here, right? It would be 176.64, and we'd divide it by 6. Okay. Now, if you want to save space and not have to write all of that out, as soon as you square that number and you get this huge number right here, you could go ahead and divide it by 6, divide it by the n, just to save yourself a little bit of time, right? So the 176.64 divided by 6. That didn't work right. Okay, divided by 6. Still a really big number, okay? Still a really big number. Let me minimize this real quick. I'm just going to erase this because I have to write so big so you all can see it, and my finger makes me write so big. So when I divided it by 6, we got 21,696 point, oh my gosh, 0.11. I'm just going to round up that 6,666 to a 11. Okay. Right, 21. So our really big number divided by 6 got us 21,696.1, and I just went ahead and rounded up to 11. Okay. And all of that is going to be over this 6 minus 1. We can go ahead and put a 5 right there because we know 6 minus 1 is 5. Okay, any questions over this step right here of what we just did? We're okay with that? Okay, good. Now we can subtract this 21,703.83 minus 21,696.11. And I get, oh my gosh, it really brings it down very small, 7.72. All of those big numbers for that, right? So the difference between our two big numbers up here is 7.72, and that's all going to be over 5. Okay. Just to save a little bit of space, I'm going to move this way. We could reduce this. So 7.72 divided by 5 gives us 1.54. You could do 4 again if you wanted it. That's pretty easy. I'm cool with that. Okay. So we get our estimated standard deviation square root of 1.544. Remember how to find square root? Right here. This one, do I have to push it first? I think so. So 1.544. Nope, that's not how to do it. So 1.544. We get 1.24. $1.24. All of that work for that little number, right? Standard deviation. This is our estimated standard deviation, 1.24. Okay, oops, making it worse. 1.24. So we now have all of that work. We now have this value right here. And so now we can fill it in here. This one's easy, easy little formula. And then we'll get this number, and then we can finally do our t-test, okay? I know I'm going way over on our time, but I want to at least get through this problem if you guys are cool with it. We're okay with it? Keep going? Okay. So now to do our standard error, we take that 1.24 and we're going to divide it by the square root of our n, which was 6. Right here. Standard error. Sorry, my dog drives me nuts. He wants to come inside, and then if he gets closed in here, he gets mad. All right, so our standard error is that estimated standard deviation that we just calculated divided by the square root of our n, which is 6. Okay, So square root of 6, we could do it on here. So 6 square rooted is 2.45. Okay, the square root of 6 is 2.45. And then 1.24 divided by 2.45 is equal to 0.51. Okay, our standard error is 0.51. Any questions on that little formula?
No.
No? Yeah, that one's pretty easy, pretty straightforward. And then our T is going to be really easy also. Oops. The only thing we haven't done is we haven't calculated our sample mean yet. We didn't do our sample mean, okay? But that's okay. If you remember, how do we calculate our average, right? Or our mean? We take the total, which was, that's right.
Divide by the number, right?
That's right, right? So we just take this 360.8 divided by 6. So that's always something you could do right away if you wanted. Just get your mean right there real quick. So it's up to you. So 360.8 divided by 6. So our average, our sample mean for this group of Snickers bars was 60.13. Okay. Okay, our sample mean was 60.13. Okay. So now we have everything we need to find our T. Looking back at this, T is equal to our sample mean minus the population mean divided by the standard error. Our sample mean we just found was 60.13. Our population mean
Is the 58.7.
Yes, exactly right, right? Is the 58.7. Excellent job. Divided by our standard error that we just calculated. So 60.13 minus 58.7 equals 1.43 over 0.51. Oh my gosh, okay, we're getting so close. We're so close. So 1.43 divided by 0.51, and we get a T value, it disappeared, of 2.80. I'm going to call it 2.80. All of that was step 3, if you can believe it. If you remember, right? Where were our steps even? Right here. Step 1, we did our hypotheses. Step 2, we found our critical values. Step 3, all the calculations. Okay, so we just did all of step 3, all of our calculations. I'm going to just do another text box here.
I have a question. Oh, No, never mind. I didn't got my reason why I was wrong.
What happened, Christy?
Oh, I put the 1.2024 instead of the 51.
Oh yeah. Yep, that's a common mistake that a lot of people do. Okay, so you are not alone on that. All right, and I'm glad you caught it on your own and you figured out what happened. Right, that's the best way to learn. Okay, so yeah, we want to make sure. I'm telling you, that's the hardest part of statistics. Is to me is sometimes just keeping all of our numbers straight, right, and putting the right number in the right spot.
It's not even statistics, just in general math. If you make a little mistake with even missing a sign, like a negative sign, it can mess the whole calculation.
Yes,
Like,
I
that's
know.
what I hate about math.
Yes, it's so right. You have to be like a perfectionist almost, right,
Yeah.
to be able to do it. I know, and I know that that's hard, and everybody makes mistakes like that. That's nothing. And so I like statistics a little bit because while that can certainly happen, right, and we can make mistakes like that, and things like that do happen. In statistics, it's a little bit more giving. You know, you don't have to round exactly right. You're not going to get it all wrong if you don't round to the right number. You know, you might get it wrong if you put the negative and it's not negative or something like that. Definitely, you could end up with the wrong results. But when I grade this, I'm going to grade you and give you points along the way. So if you write your hypotheses, that's points right there. If you find your critical value, that's points right there. The step 3 calculations, which is where people might have trouble, this one, it's points right here and it's all on its own. The points for this one and the points for this one have nothing to do with step 3 points. Okay, if you fall down right here and you make mistakes in step 3, then it's only points off here. Okay, you won't miss the whole thing. And then step 4 is a little bit, you know, this one is contingent on how you did in step 3 and step 2. Okay, but you know, it's like a 50-50 guess at this point. You're either going to reject or you're going to fail to reject. So, and there's points, so you have a pretty good shot of maybe guessing right. And it's just points right here also. So again, you know, like in math, if you make one little mistake, the whole thing comes crumbling down and you miss the whole problem, right? In this one, if you make a wrong calculation somewhere, you're still going to get points along the way. Okay, so hopefully that eases your mind a little bit about that one. So our step 4 is make a decision. I do not know how to spell, guys. Like that?
No, it's with the C, D, E, C.
Oh yeah, it's like decide, right? Yeah. So yeah, whenever I wonder where Matthew got his dyslexia from, sometimes things like that make me go, huh, maybe it was me. All right, so step 4, make a decision. All right, now how do we do this? We're trying to decide whether we reject or we fail to reject. And what we do, remember, it's all based on our critical values that we found in step 2. I think it was 2.571, yeah. Right, we said it was 2.571. So we'd have negative 2.571 here, and we'd have 2.571 here. And now we take our t-value of 2.8 and we try and see where it fits. Where would 2.8 be on this number line? If this was an imaginary number line, right?
It would actually exceed.
It would, right? It would. Yay! It would exceed the 2.571. It's not negative, so it's not on this end, right? It's
Uh-huh.
over here somewhere. Yay! It's like a drum roll. Drum roll, right? So 2.8, I don't know, would be somewhere right here, 2.80. And it really doesn't matter, right? We're just drawing it for funsies, okay? So if our t-value exceeds or finds itself in the rejection region, what do we do?
We accept. Oh no, sorry. We reject the null.
Yes, we reject the right? No, the null. We reject the null hypothesis. Woohoo!
Since,
Uh-huh.
okay. Oh, so we just put since the t value value is exceeding the critical value, our decision would be to reject the null.
That's right. That is exactly right, right? Since our t-value here of 2.8 that we calculated right here, right? 2.8, it goes beyond our critical value. And so it finds itself in the rejection region. Remember, anything beyond the critical value is the rejection region. So we get to reject the null hypothesis, okay? Now, if you wrote that for step 4, I would give you credit, okay? You would get full points for that. I would like you to try and go beyond and write a little conclusion, because it's always nice to be able to say, so what does that mean? Okay, so what does that mean? What does it mean? We rejected the null.
So there is, meaning that there is a difference.
Yes, right? There is a difference. Can you say which way, Natalia?
So there is a difference in weight
In weight and
between the Snicker bars, the sample mean of
uh-huh.
Snicker bars, and the company's claim of 58.7 grams.
Yes, beautiful. And is the sample, do we on average get more Snickers or do we get less than what the company claims?
Give more.
Yes, awesome. That's exactly right. And that's how we do that, okay? You could write something very easy at first, right? There is a difference. And then we could say a difference in what? In weight, right? Of between what? The sample mean and the company claim, right? There is a difference in weight of the sample mean and the company claim. You could say this too. There is statistically more, I don't know, weight compared to the company claim. I don't know. I got that's kind of, I don't know. My head just went there right now. Obviously, there's many different ways to write it. Okay. The conclusion is just kind of a, so what did you find? Or if you had to explain it to your mom, or if you had to explain it to your grandma, okay? Or even you had to explain it to your little brother, and you had to put it in such easy words that someone else would understand. Okay, so what does that mean? What did we find? We found that Snickers actually weigh more than what the company says they will. Okay, and on average, if you've ever been in the business world, that will be the case because they don't want to get sued, right? You know, there's some cynical person out there that's going to weigh their Snickers bar. And if it weighs less than that 58.7, they're going to write a nasty letter to that company. And they're going to say, you lied to me, and I did not get what I paid for. Okay, so they're pretty much always going to be over what they claim. Okay, so just a really easy way to go back and say, this is what I found. Okay.
I have a question.
Yeah.
Okay, so right now we rejected the null, right? When you accepted, would it have to be that exact number that we got, the 2.5171?
I got you. So, okay. If it's exactly equal, it just worked out that our T came to 2.571, then you can still reject, okay? Because it's exactly 5%, right? If it was 2.56, then you accept, okay? If it was 2.569, you still accept. You would not reject because it would be on this side. Susanna, that's a good question, and it is good to know. I have never in my 10 years of teaching ever found a T that equals exactly. I guess it would obviously could happen for sure, but I've never seen it. I've never seen it happen. It's always one way or the other.
Okay, I was just curious.
Yeah, I've never seen them in examples. I've never seen it on a test, them be like mean like that and do that. Obviously out in the real world, that could happen. If that happened to a researcher, and they say their T was 2.569, so close to that.
So close. Uh-huh.
Instead of scratching the whole study, I would say they probably would go out and buy one more Snickers bar and then just change everything. And I bet it would push it over.
Oh, okay.
Yeah,
I
something
see.
like that. Because it's like it's showing that it's getting really close. You're on to something, And so they probably would just go get another person or another, observation. If it was something way down here, very close to zero, they're really not finding a result, a difference between those means. They've got to reevaluate what they're doing completely,
Okay.
But that's a really good question. Thank you for asking that. So if it is exactly equal, then you go ahead and you reject. If it is 1 over, you're good on doing rejecting. If it's 1 under, as bad as that may be, you're going to go ahead and accept the null hypothesis.
Why would you reject when it's exactly that number?
Because it's exactly equal to 5%, that critical 5%. So you get to say that you have, the probability of making a false positive is 5% or less, right? It's exactly equal to that critical 5%. If it was just 1 below this way, then you are technically above that 5% probability. So, and I guess if that happened, let's just say if it happened in our class, we go ahead and reject. If you're out in the real world and you're doing statistics and you come up with something like that, I guess then it would be a call. It would be a gut call on your end, on what you want to do. But no one would question you on that, because it's exactly equal.
Okay.
Yeah. So isn't this fun, huh?
Yes. I have a question. Whenever you're finding the degree of freedom, do you always use that chart, or like where do you get those numbers?
Okay, good question, Christy. So yeah, degrees of freedom, right, is always n-1, and we're always going to find our critical value. Remember, all of these in here are our potential critical values, okay? And where we get this chart, In our book, it's on page 388.
88. Okay.
Let's see, I'm just going to go ahead and type it here. Critical values. Oops. Page 388. Okay. In our other, in the other slides, Christy, there's a picture of the complete chart. Okay, and I will also, I think I said I was going to do this with the normal distribution and I never did, which I apologize. I will, in our course documents, I'll put the T-table as a standalone chart or something, a page, if you guys want to print it or something like that. Okay. So it's in the back of the book, page 388. It's the complete table. It's only one page, okay? And that's how you find that. Look at, oh, that's getting later. Okay. All right. So tomorrow, guys, I've always found that when I do it twice, the first day I kind of talk and I ramble a lot. The second day is more concise. I become a little bit more efficient in what I want to say. So my class tomorrow will probably move along quicker. And maybe, I'll go through an example. I'm going to use a different example than today. Okay, so if you want to watch those, if you want to attend or if you want to watch the video tomorrow, it's going to be another example, different numbers, okay, but I'll do the same thing. So just another way for you all to practice, okay. I promise I'll get a homework up that will just be different things, practicing talking about the hypotheses, practicing finding the critical values, okay? I could, if you want, we could do a step 3 and you guys could try and do it all on your own if you would like to, and we could check in along the way and see how we're doing. And then a practice of step 4, making a decision, okay? So I'll get a homework up for you all to do. Okay, and you can check in with me and ask questions and see how we're doing, okay, through email or discussion board or whatever, okay?
What about the other slides in the presentation?
Yeah, so I'm not going to do that yet, okay, because I feel like this one was a lot. This is going to be effect size, and we'll talk about effect size. It's a really easy thing to calculate. Okay, and we'll talk about effect size in a little bit. This is our next chapter. This is 2 samples. Okay, this is 2 sample t-tests. You can see our t's become a little bit different. Okay, and then our independent sample. Oh, I don't have the formula for the independent sample. Which is probably a good thing for you guys because it's a really big, scary formula. Not to scare you, he just looks really ugly, but he's pretty easy to calculate. So I have to get that up. So we're just going to save this right now because these are 2 sample designs. All right. Right now, we're just working on the 1 sample. Okay. Cool. Cool beans. Okay. All right. So any other questions? No? Okay. All right. You guys did really good. Okay. I'm gonna right now convert this and do all that work of getting it on YouTube and all of that stuff so it's available for everybody. If you come back tomorrow, I'll see you tomorrow. If not, it will be a different problem. You guys can watch that on the video. Okay.
Thank you.
All right. Thanks, guys.
Okay. Thank you.
Thank you.